Chad Tietz. I'm Wireless Field Applications Engineering Manager located in San Diego, California. Today, what I would like to do in this brief 45 minutes to an hour is introduce you to SmartStudio New Radio, or what we call SSNR. And I will briefly review SSNR and move right into a 5G NSA FR1 demonstration. So again, thank you for your attention today, and let us begin. So SSNR, what exactly is it? So SmartStudio New Radio, in short, it is an extremely powerful interactive application. And this application drives the Anritsu MT8000 and MD8475B for performing data throughput testing and a variety of software, regression, and functional testing. There are many key benefits, but here are a few points. One, it's very quick and easy to develop test cases. And it actually allows you to develop test cases that will not go outside the scope of 3GPP. So what that calls for is that you will not have any user errors when you're creating a test case. Another thing that we support here is SMS, MMS verification testing with the SMSC, CMAS, ETWS, emergency alert verification with the PWS server that's installed, and also VoLTE and voice over NR with built-in IMS servers. There are also a variety of ways that we could do trigger functions for sending failure type of scenarios via RRC and NAS messages. In addition, there's excellent logging capabilities on this particular setup. So here's a brief look at SSNR and how the interactive GUI looks. You can see there are a few little points that I wanted to really stake out for you. If you see there's a UE state machine status window. That illustrates the status or the state of the UE that's under test. So if the UE is powered off, there's no RRC messages being exchanged with our software. Once RRC messages are being exchanged, then it will show you the whole process throughout the connection state. Down at the bottom, you'll also see that there's a PDN sequence log, message log, and trigger windows that offer easy access to logging of internal actions. Not only that, but the message logs also will point out some of the RRC messages that are being exchanged between the UE and the network. The PDN status window will actually show you whether or not you have a PDN connected and what type of IP protocol it is using and what IP address it is connected to, or APN that it's connected to. Up at the top, you'll also see that there are some logging icons and our application server access tools as well. And off to the right, there's a common window which indicates like the network configurations. And you'll see two tabs off to the right as well for the NR cell parameter settings and the LTE cell parameter settings. So in brief, what I want to do is go over some of our logging capabilities, and because this is a very powerful tool to use within SSNR. And if you're familiar with SmartStudio in the past, you may have been familiar with this as well. So we have SSNR trace logging capabilities. This is where you could see the exchange of messages from the network to the UE and vice versa. This is very powerful because you could actually go in and see the actual messages all the way down to the file layer messages being exchanged to do further troubleshooting and actually see whether or not there are like CRC errors within the messages, especially like during 5G ratchet attempts. There's also a really good feature here that is actually pointed out is a search function as well. So if you know that you're looking for like uplink ratch messages, you could type in ratch and you'll actually see all of those messages that come up with the ratch. Some additional logging capabilities in SSNR include the power monitoring and measurements. So the power monitoring actually indicate like what the uplink power measurements are and what the downlink power is being sent out from the call box. In the NR measurement side, you can see the various rates for physical MAC for the downlink and uplink share channel and RLC parametrics, PDC parametrics as well. SSNR throughput monitor is also a really good way of seeing a graphical representation of those previous measurements that I was talking about. So as you see here in that first window on the left, you could see a very high data rate, which is around 1.3 megabits, or actually 1.3 gigabits of data being pushed through the Mac PDU. Where down below, where you see the little green square, I have extracted that information and stopped the NR downlink measurements. So in that way, we could see all the other measurements that are being recorded, such as the LTE Mac PDU information and the NR uplink Mac PDU information. For today, our demo is a fairly basic setup, as you can see here. So we have an MT8000 and the MD8475, which is going to be controlled by an external PC that is running SmartStudio NR. And everything is basically connected to an Ethernet switch. There are a few sync and output buffers that are connected between the two call boxes. And you may have recognized this as well from the previous demo with the MT8821 and the MT8000 for RF measurements. One of the key points here is that we do have the server connected to what we call our data test unit or data test module. The data test module connects to the external server via a fiber 10 gigabit Ethernet cable. So this is where we can actually send data to an external server to test IP layer throughput. It's very similar also to the RF measurement software where you can do IP throughput as well. But don't limit this to anything else, meaning you could actually connect this port to an external gateway, for instance, to access the internet as well. So if you wanted to do YouTube streaming videos, or like if you had a 4K server externally connected, you can connect the call box and stream this information to the device under test. So let's move on to the SSNR live demo. I hope everyone can see this. So basically what I am connected to now and what you see is SmartStudio NR. And this is the common interface that we are going to interact with the majority of the time. Over here to the left, as I indicated earlier, is your UE status. Right now, I have a device connected, but as we can see, I am in airplane mode. If I go to our simulation parameter setup, which is located here at this test equipment, icon, or I could go to Setup. To Setup, go to Simulation Parameter. This will bring up another window. And what this window indicates is the configuration of our network. So here, for now, on SSNR, we have an NR setup and LTE as well. For machine config, we can have a drop down here. And what you'll notice is we can have multiple MD8475s connected. And the main reason for this is due to the amount of layers that we can support for LTE. So if we wanted to do 20 layer type testing on LTE along with 5G NR, we would need 2 MD8475Bs to support that. And this next little window down here, we could tell the MT8000 which RF connectors to use. Right now, since we're doing FR1 testing only, we're going to be using our RF submodules. However, if we wanted to do FR2, we can actually put in RF converter, and that will set up the system to run with the millimeter wave RF up converters. And then the same thing with slot number 2 as well. So if you didn't have slot number 2 populated or any hardware in there, you could actually indicate that there's none available. For RF converter, the same, and RF submodule. And then down here, this RF submodule indication here will tell you which ports you want to use on the MD8470 or on the MT8000 itself. The simulation model here indicates one NR cell, one LTE cell. So if you needed to test maybe like 4CA on the NR cell, then you would turn that up to four cells for the NR cell itself, or BTS itself. Same thing with the LTE cell. You can increase the values for that. Today, we're only going to do one carrier. The UE that we are using only does support one carrier. If you click apply here, this will update the whole setup, and you can come over to this blank or this white window and validate the connections. So as you can see here, these are the rear connections for the call boxes. So again, this is eliminating any user configuration errors because everything is alive and you can view everything. The front panel connections tells you where the UE is going to be connected via RF connections, and then how the call boxes are going to interact with each other. Down here for MIMO, if you need to do 2x2, 4x4 MIMO, then we will select those values as well. And the same thing for LTE, whether or not we're going to do 2x2 or 4x4. Carrier aggregation, if we are going to be performing any carrier aggregation over LTE, right now it says none because of the fact that we only have one cell configured in our simulation model. MD8475B connectors that we will be using mainly stay as defaulted, as you see here. However, there are some instances when you start doing carrier aggregation where you may need to do some sort of RF sharing. But we can leave that as another note later. Some common parameters. So you have security, whether or not your UE is supporting security, yes, or if it's enabled to off, or if you're running fake security. We also have a built-in AWGN generator for LTE. Status change information. So this is related more to the LTE status change. So basically this is very useful if you're doing like battery life testing. You can eliminate the amount of time that the UE is actually in communication state. So if you are sending data to the UE over LTE, but then you stop sending the data, during a certain amount of time that you indicate here, we will shut down the RRC connection and send you to idle state. Trigger information is very valuable if you're going to be testing various failure type of scenarios. So you can actually force like authentication failures. You can do several different like PDN connectivity requests. So if there's a request that comes in, do you want to accept it or do you want to reject it with a particular cause? And what this does, it actually tests the modem software when an incorrect message comes to the device. How is the device going to react? Is the device going to reboot? Is the device going to crash in its software? So these trigger functionalities are very useful in testing. Message log monitor, there isn't anything in here. However, what this does, you can point out a particular IE in an RRC message that you're searching for. And if you indicate that, it will flag that IE during your logging. So that's actually a really good feature as well if you're looking for a particular IE value. PDN parameters. As you can see here, we could set up to 8 PDNs, so 8 different type of bearers. But within each one of these, you can actually connect up to 7 dedicated bearers within there. So you get one default service and then dedicated bearers. So what I did, I actually just double clicked on PDN1 and brought up this window here. And here is the IP address that I'm assigning the UE, both v4 and v6. Up here where it says check APN, it's starred out. It's because I'm going to accept, or I'm telling SmartStudio to accept any connection or any APN connection. Under Bearer tab, you could select what type of service you want to run. And we'll get into that in a second. But if you had a particular service for like max guaranteed bits here to run like a video streaming software, you could configure and make your own services that can be recalled for this bearer. For PDN gateway, again, all we're doing is we're accepting any, basically, with this checkbox, we're depending on the UE to send us whatever APN connection that they choose. If we wanted to say that this PDN, because we set services up for it for a streaming online service, we can deselect this checkbox and actually put in an APN for that service. So when the UE connects, then it will connect over those particular services. Right now, we'll keep this to depend on the UE. The network connections. So one, we could forward this PDN off to our IMS services, or we can use these following IP addresses. So as I was mentioning at the beginning, if you wanted to forward to an external server outside of SSNR, you can put those IP addresses here, and we will provide you that pipe through the service gateway and the packet gateway out to that particular service. If you're doing any type of PCSCF or IMS external testing, we have abilities of adding multiple PCSCFs because of the fact that if you fail on this one PCSCF, you will retry on this other PSCF. So all this information, if we enable this, will be sent over your PCO message. Okay. So here's where we could go into our services. So if we wanted to configure any default bearer services or dedicated bearer services. So as we look into this, we could add, and then another window pops up. We can name this service, for instance, test serve. We could give it a quality of service. Maybe we want to set it to 5. We click the quality of service button, and then we can go in and set our max bit rate, our guaranteed bit rate, and various other R99 quality of service functions. Traffic flow templates are also supported. So if you have a TFT IE that you want to use, you can input that by selecting these radio button inputs. RLC PDCP responses, so whether or not it's acknowledged mode or unacknowledged mode. And some RLC SN field information. Right now, you can see that ROHC is disabled in here. It is because we currently do not support that for these services. If you are testing over just LTE only, we could have that option enabled. Then once you have done that, your service is here. So if I go back to the PDN parameters, double click here, PDN parameter 1, go back to bear, and I go to dedicated 1, secondary 1, you'll see that that service has been created. So I can still come into the QoS and make some changes here, but I just wanted to make sure that you were able to see that you can create your own services and apply them to each one of your PDNs. And then, of course, you have USIM and SIM information. So this setup or our SSNR application can accept any type of SIM, just as long as you understand what the K value is and the authentication type is. In addition, our setup is also qualified to run with the Compreon software to do USIM validation. So creating new USIMs is very easy. All you have to do is click add, and then you can make a copy of a particular one and click OK, and then there is your new USIM. And then you can come down and you could save or load any pre-configured simulation parameters. So cell parameters. So I went here to this little cell site icon, or again, you could go to the setup and click cell parameters as well. Cell parameters, you'll see NR and LTE. For those of you who are familiar with SmartStudio in the past, we also had the 3G technologies. Since this SmartStudio NR is not supporting the 3G, 2G technologies, you're only going to see NR and LTE. So the way you configure new cells is very simple as well. This is where you can configure your cell and save them and recall them for later usage. So I'm not going to go into every single parameter here, but at least you can kind of get a good view of some of the NR cell parameters that are available. Here are some of the extended NR cell parameters as well, along with connected DRX. And then, of course, our LTE parameters here. So there's a long slew of parameters that we can configure for LTE as well. Now, one thing I want to point out is currently in this version of software, we are not doing any, we're doing mainly fixed scheduling based on your manual input. For LTE, we actually have the capability of doing dynamic scheduling as well. And the dynamic scheduling is on our roadmap to be coming out here within the next month or two. So as you see here, it's all static scheduling. Okay. So let's go ahead and move on here to once we have our simulation configured and we have our cell information configured, we can look in our tabs here. For this particular UE that I'm testing, we're going to do band N78 for NR, 4x4 MIMO. And for LTE, since this is NSA, we're going to do band 1 for this particular UE. For this demo, I'm using Visor to communicate with the UE as well, and it's the same UE as what you saw earlier today for the RF setup. So I'm going to go ahead and click airplane mode, turn that off. So as you could see there, you could see the UE going from power off state to registration to communication. And you could see how it is connected in this network. So it is connected only over LTE at this time. If we wanted to look down here at some of our message logs, you could also view them for the LTE exchanges. Right now, there's only LTE exchange happening on this window. If you need to see any NR messaging, you have to go to our trace log tool, which is up here in the menu bar. And then you'll be able to see the more information as well. So how do we add 5G to this call with SSNR? It's actually very simple. And as I explained before, there's an easy way of going in and creating what we call a test case for mobility or adding additional carriers to our cell. So what we could do, other than using some of the built-in test cases that we have, we could go up to this icon where it says test case editor. And with this test case editor, it actually brings up a pretty neat GUI for us to begin creating a test case or creating a handover scenario, if you will. So in our simulation, we have an NR cell and an LTE cell. So we got NR and LTE. If we do this drop down, you'll see quite a bit of different variations. But SmartStudio understands what type of simulation that you have running. So initially, it's going to bring up this NR1 cell and NR our LTE one cell. We could go to procedure. We could do a measurement, meaning we could actually trigger off of like any A1, B1, B2 type of measurements, or we could just do what we do is multi-cell. So this is for carrier aggregation, or even just adding another cell to the UE. Here we'll say that it needs to be active and whether or not we're sending any RRC messages over SRB3. This particular UE doesn't support SRB3, so we'll leave this deactive. We could go to power control. We can actually tell SmartStudio to adjust the power levels for the NR cell to a certain level before we actually send that message to add the NR cell. Or we can turn power control off. And what this means is that we're going to already have the levels of each cell to a point that we know that it should attach successfully. For measurements, so this is actually a really good feature as well here. And a lot of customers really like this, where we could come in and say, we want to do measurement reports. And once we get a measurement report, we want to add the cell. So we could go into measurement, and then you'll see that it enables a couple of other icons here. So there's a procedure trigger, and an RRC reconfiguration, and a gap. So if you need to enable gaps, you can actually come in here and enable the gaps and give it a value. The RRC reconfiguration, this gives you the ability to modify your RRC reconfiguration. So as we look at this, we're saying here, by default, it's an event A1, release 15, RRC reconfiguration setup message that we're going to send the UE. But as you scroll down, you can actually go in and modify certain parameters within this RRC message. For instance, say if I wanted to change this event A1, I double click on that IE, and then I get this drop down to where I can put in any additional event I want, particular to event A. And then I could do the same thing with any of these highlighted items. I can always go in and modify these values. If I wanted to do a different type of event, so like a periodic maybe measurement on the NR intrafrequency, it will adjust that downlink DCCH message appropriately for that message. Another really good feature that some of our customers really like to see is that down here, we have the hex information. So if you're out in the field and you collect logs for a certain situation, you can actually plug that downlink DCCH message information into this window and run that particular scenario. So it's kind of like a field to log type of scenario, but there are some limitations to it because it's not like we have a tool to convert it. It's more of you have to be able to get this hex dump information and plug it in here. So then once you're really done with creating your test case, then you could save it. I'm just going to go ahead and cancel out this window. And I'm going to go and run a built-in scenario without measurements to add the NR cell for 4x4 MIMO. So while we run the test case, I want you to keep an eye also on the trace log measurements or the trace logging here, as you'll see the 5G ratch occur. In this window down here, in the message log window on the main screen, you'll see that I'm going to clear it. And then you're going to actually see the RRC reconfiguration message being sent to the UE. So we'll go ahead and run this test case by clicking Start Test Case. There's your RRC reconfiguration message. We received the response back as RRC reconfig complete. And then you'll notice that there are some populated areas up here. So our rate that we are testing at right now at a MAC level is 1.3 gig, and our uplink is at 19 meg. As you can see here, we are doing split bear as well, SCG split. We'll go to the log as we scroll up here. Let me pause it. So you can do live debugging as well. But you can see here we send, we have a little bit higher in this log. We've sent the RRC reconfig, and then you can see the 5G ratch message here. So this is the L1 message coming from the UE. And then you can see that we have sent our response. And then there's a couple of macros that are running based off of like the CRNTI information that goes back and forth to ensure that we are also setting up the SCH, the downlink SCH channel successfully. What I have done here, I've gone in and if I go into the filter, I have turned off all the PHY layer filtering here, because if I did not do that, it would be a lot of logging that we would see. So I have disabled that information, and I've also disabled like all the broadcast channel information as well, just to minimize the amount of logs that are coming through. So now what we could do, we can actually go in and let's monitor our output power from the call box and what our uplink power is from the UE. So if I spread this out, the monitor window, which is also accessible from the toolbar, we can see we are broadcasting at 3.5 gig. The total downlink power is about -23. And as we scroll down here, I can close down this SCS 15 kilohertz because we are running at a subcarrier spacing of 30. And then this is where we could see our uplink power information from the UE. In addition, we could go to our measurements window. So again, I showed this to you previously in the presentation. And right now, this is paused, so I'll click Start. And what this is going to indicate to you is the amount of MAC PDU sent to the UE and any new transmissions that are needed. So one of the key things to do if you were trying to monitor this for like any type of bit error rate, if you saw a difference between this TX rate and this TX throughput, then that means that there's some sort of downlink blur that is occurring. And again, you could see over here for the amount of AX and NAX, it's a pretty clean channel. As we scroll down this list, this is where we'll see our PHY layer or our MCS reporting. And we're reporting at MCS 27. For RLC stats, you won't really see much here until I actually start sending some additional data. So, and the same thing with the PDCP. The reason why you don't see any RLC information here is because I didn't have this running during the ratch attempt. So you don't see any accrual of that ratch attempt. So in this case, what I can do now, I can go to my command prompt and ping the UE, which is at 192.168.1.1. I'll do a continuous ping on this. So now we got a full IP connection with the UE. And you can now start to see the RLC statistics occurring. And again, you can also look at your PDCP information as well. Now, depending on how many cells or carriers you have connected, which is up to 8 here, you would have to select each one of these to monitor how those statistics are running for each cell. Now, if you wanted to see the aggregated, you could click on the aggregated tab, and you could see the aggregated value between LTE and NR. So with that, that pretty much is what I wanted to demonstrate to you today. I could get into a little bit more of the trigger information if you would like, but our main point is the ease and use of the software application. So.
Thanks, Chet. I have questions for you.
Okay.
Okay, well, let's start out with a couple here. Is it possible to automate SSNR application?
Yes, SSNR can be automated via various methods. You could either use GPIB commands via LAN connection or via your Ethernet connection. You could also use the built-in APIs that we give you access to. And we also have another product called SmartStudio NR or SmartStudio Manager, which if you're familiar with what Rapid Test Designer is for some of our chipset manufacturers, it's a flowchart diagram for automating our equipment.
Okay. Next question. Can SSNR allow the device under test to connect to external servers or the internet, for instance, YouTube or remote device configuration services?
Yes, and again, that's a lot of our application developers that are our customers who develop applications. It's very difficult for them to go out and utilize like the over-the-air, the actual carriers that are over the air based off of capacity. So they're unable to actually test and validate the performance of their software. So they use SSNR or SmartStudio or test equipment to be able to connect to the internet and test their application on their devices.
Okay. Does SSNR support MMS testing?
Yes, and that is one thing that we do, which we know a lot of other customers or a lot of our other competitors do not support, where we use a third-party software called Now SMS, and we run that server software on our call box. And whenever you send a message to, or an MMS message to that service, then you're able to send those MMS messages, receive any type of MMS message that you want to also generate from now SMS. So again, a third-party tool is necessary for that, but our SMSC supports it.
Is field to lab importing supported? Can we capture logs from the field and import the data to SSNR software?
Currently, right now, as I illustrated in the RRC reconfig message that I discussed a little bit earlier, we can only support certain amount of RRC messages for adding like SLs or manipulating SIB parameters and such. So I know I didn't get too much in depth on some of the LTE parameters just because I was more focusing on the 5G NR aspect of things and some of the applications. But yes, we can take a limited amount of hex information and import them into specific messages.
Okay, I've got a couple more. Is it possible to check the UE capabilities?
Yes, and if you don't mind, I would love to go back and show you this information.
We have time. I have one more question, but we have plenty of time.
Okay, so here, let me go ahead and what I'm going to do, I'm going to release the NR cell, and then I'm going to power the UE off, or put it in airplane mode. I'm going to clear out my message log information here, and then I'll bring it back online. So as you see here, as we go through these log messages here, our message logs, you can see all the different RRC messages being exchanged. Authentication request, authentication response. Then we come down and we do a UE capability inquiry. So there are several different ways to actually view the UE capability inquiry. We could double click on the UE capability information here, and then it brings up a window. And then we can go down to the UE capability information button. And as we come up with that, you could see that there's this particular UE supports a very minimal set of channels, as you can see here. But one other good thing about this is that we could go into our RRC messages and actually look at the feature group indicators as well. So rather than scrolling through this long log of what features the device supports, we break it out for you here. So the feature group indicators, whether if it's release 9, release 10, so we'll look at release 8 and we'll view them. We break them up for you to show you what exactly the UE supports. So if you're looking for something in particular to maybe packet switch handover, and maybe for some reason the UE is failing packet switch handover, you could go in, look at the feature capability indicator or feature group indicators and see, oh, well, this is true. It does support it. FGI 8, it's supposed to support it. Then what else is my other issue? Like what can that other issue be? So it's very valuable